Now, Bill Nye takes us on an even more exhilarating journey, diving deep into the latest groundbreaking discoveries made by the James Webb Space Telescope. These discoveries are pushing the boundaries of our understanding of the universe, offering us glimpses of cosmic phenomena from over 13 billion years ago, forever altering our perception of the cosmos, and our place within it. The James Webb Space Telescope, often called the successor to the Hubble Space Telescope, represents one of the most significant advancements in space exploration in recent history. It is a technological marvel that is giving us unprecedented views of distant galaxies, stars, and even exoplanets, offering insights into the universe's distant past. The images it captures are not only stunning, they're reshaping the way we think about space, time, and the potential for life beyond Earth. But what makes these images from Webb so special, and why do they defy our previous expectations? The journey to creating the Webb telescope was no easy feat. It was the result of decades of collaboration and hard work by NASA scientists and engineers, who meticulously planned and executed its creation. After its launch on Christmas Day 2021, the telescope embarked on its journey to its final orbit, where it would begin its quest to peer deeper into space than ever before. Over the following months, the various stages of its deployment unfolded smoothly, with scientists holding their breath as each step went according to plan. By the end of June 2022, Webb began transmitting its first images, and they were nothing short of revolutionary. For decades, astronomers had been using the Hubble Space Telescope to study the universe, but Webb's advanced infrared capabilities have opened up entirely new realms of discovery. Webb can observe light from galaxies that formed just a few 100 million years after the Big Bang, shedding light on the formation of the very first stars and galaxies. In fact, some of the galaxies Webb has identified may be up to 150 million years older than the most distant galaxies discovered by Hubble. These ancient galaxies are pushing the limits of our understanding of how the universe evolved. One of Webb's most extraordinary abilities is its ability to study exoplanets, planets orbiting stars outside our solar system. Thanks to its infrared sensitivity, the telescope can analyze the atmospheres of these distant worlds and determine whether they might have the ingredients necessary to support life. For the first time, scientists are able to directly observe the compositions of exoplanet atmospheres, unlocking clues about their potential habitability. Perhaps one of the most iconic images captured by the Webb telescope is that of the Pillars of Creation, a star-forming region in the Eagle Nebula. This structure has been a favorite of astronomers since it was first photographed by the Hubble Space Telescope, but Webb's infrared capabilities have allowed us to see something Hubble couldn't, the very process of star formation. The infrared image reveals clusters of protostars, young stars in the process of being born, each one a tiny red dot amidst the vast clouds of gas and dust. Bill Nye explains that these protostars are not yet burning hydrogen. Instead, they are in the process of gathering mass. As more material is pulled into the center of these protostars, they will eventually become dense enough for nuclear fusion to begin, igniting a star. This process, known as stellar nucleosynthesis, is a crucial step in the formation of stars like our Sun. The colors you see in these images represent different wavelengths of infrared light, which is mostly invisible to our eyes. The blue portions of the image are the only visible parts, while the red hues represent radiation emitted by the protostars. Bill Nye notes that the red radiation we see here is emitted at wavelengths 6 times longer than what the human eye can detect. This is a perfect example of Webb's ability to see beyond the visible spectrum, providing us with a fresh perspective on star formation and the birth of the universe. Webb has also made major strides in the search for exoplanets. The first confirmed exoplanet was discovered in the 1990s, and today there are more than 3,000 known exoplanets. However, direct images of these planets have been rare. That is, until September of last year, when Webb captured the first direct image of an exoplanet, called Hi 6542-6b. This massive gas giant is about 12 times the size of Jupiter, and it orbits its star at a distance 100 times greater than the distance between Earth and the Sun. Thanks to Webb's powerful infrared capabilities, scientists were able to capture this exoplanet's image by using coronagraphs, which block out the light from the central star and allow the planet to be seen. Another fascinating discovery made by Webb is its observation of the ghost galaxy, M74. While M74 is difficult to see with the naked eye, Webb's infrared imaging has revealed stunning details. The new images show structures that resemble fibers of heat-emitting dust and gas, radiating outward from the galaxy's bright center. These structures, depicted in vibrant electric blue, provide astronomers with new insights into star formation within M74's spiral arms. Combining both Hubble's optical images and Webb's infrared data has created a composite image that highlights star-forming regions and allows astronomers to study the galaxy in a way that was never possible before. The Webb telescope also provided a groundbreaking image of Wolf-Rayet 140, a massive star nearing the end of its life. Known for its unique diffraction patterns, this star is surrounded by concentric rings that are caused by the interaction between Wolf-Rayet 140 and its companion star. These rings are not just beautiful to look at, they reveal the complex processes that occur when a massive star sheds its outer layers, enriching the surrounding space with elements that will eventually form new stars, planets, and possibly life. Perhaps most mind-boggling of all are the discoveries Webb made about some of the oldest galaxies ever observed. In December last year, scientists announced that they had detected 4 galaxies dating back 13.4 billion years, just 350 million years after the Big Bang. These ancient galaxies were thought to be beyond our reach until Webb's technology made them visible. By measuring their redshift, astronomers confirmed that these galaxies are much older than anything previously observed, offering an incredible glimpse into the universe's earliest moments. And Webb's explorations don't stop there. The telescope has also studied planets in distant solar systems, like WASP-39b, a gas giant located 700 light-years away. Orbiting its star much closer than Mercury orbits the Sun, WASP-39b is a planet unlike any in our solar system. Its atmosphere, thick with clouds containing sulfur and silicates, was studied by Webb's spectrographs, which identified the presence of carbon dioxide. This discovery opens new doors in our search for planets that might harbor life. These discoveries are just the beginning. As Webb continues to explore the universe, it will help us answer some of the most profound questions in science. How did the universe begin? Are we alone in the cosmos? How do stars and planets form? With every image and every new finding, we're one step closer to unlocking the mysteries of the universe. So, what do you think about these incredible revelations from the James Webb Space Telescope? Drop your thoughts in the comments below.